In today's video, we are going to continue our lesson on mensuration. We are going to talk about the parallelogram, the trapezium, rhombus, and a kite, and how to find the area and perimeter of these plane figures. Now, if you are new here, consider subscribing to this channel. Make sure you like this video, you comment under the video, and share this video to all your friends. Now, let's start off with the parallelogram. So a parallelogram is a four-sided figure with the opposite sides being equal and parallel as well. So this is how a parallelogram looks like. Let's say this is A, B, C, and D. Now AB is called the base of the parallelogram. DC is also called the base of the parallelogram. And then we have AD and then BC to be the other sides of the parallelogram. So for a parallelogram, we say that the opposite sides are parallel. That is, AB is parallel to DC, and they are equal in length as well. The same happens to AD and then BC. They are also parallel and equal in length. So the side AB is equal to the side DC, and AD is also equal to BC. AB is parallel with BC, and AD is also parallel with BC. Now we also have what we call the height of the parallelogram. Now this height is perpendicular to the base of the parallelogram. So we have the height, which is at 90 degrees to the base of the parallelogram. The sides are not at right angles to each other. Okay, the sides of the parallelogram are not at right angles to each other, and the opposite angles of the parallelogram are equal, and the diagonals bisect each other. Now let's move on to the perimeter and the area of a parallelogram. So the perimeter of a parallelogram is the sum of the lengths of all its four sides. So the sum of the length of all its four sides. Now we have two base lengths, that is AB and then DC, and then we have two side lengths, BC and then AD. So we say that we have B plus B plus S plus S. Now this can be simplified as 2 times the base length plus 2 times the side length. So basically, this is how to find the perimeter of a parallelogram. Now let's talk about the area. So the area of a parallelogram is given by the length of the base. So the base length times the perpendicular height. The perpendicular height. So the area of a parallelogram is given by the base length times the perpendicular height. So always the height must be perpendicular to the base of the parallelogram, and the height and the base length must always have the same unit. Now, given that we have a parallelogram ABCD with a base length of 37 meters, and then we have the side to be 25 meters. Assuming that the perpendicular height is 19 meters, so we are going to find the area and the perimeter. Of this parallelogram. So for the area, we are saying that the area of a parallelogram is given by the base length times the perpendicular height. So we have the base length to be 37 meters, that is AB, the side AB. So 37 times the perpendicular height, that is 19 meters, so times 19. Now 37 times 19 gives us 703. So we have 703 meters square. That is the area of this parallelogram. Now let's move on to the perimeter. So the perimeter is given by 2 times the base length plus 2 times the side length. So we have 2 times the base length to be 37 meters plus the side length is 25 meters. So 2 times 37 gives 74, and then 2 times 25 we have 50. So when you add the 2, 74 plus 50, we have 124 meters. So this is the perimeter of this parallelogram. Now let's move on to the trapezium. So a trapezium is also a four-sided figure with one pair of the opposite sides being parallel but not equal in length. So assuming this is our trapezium, let's say this is A, B, C, and D. We have one pair of the opposite sides being parallel but not equal in length. Also, we have the height of the trapezium, which is at right angles or 90 degrees to the side AB. So we have H, which is the height of the trapezium. Now let the side DC be A, and then AB be B, and then we have this side to be C, and then this side also to be D. In that case, the perimeter of a trapezium is given by the sum of the lengths of all the four sides. So that's going to be A plus B plus C plus D. So we have A plus B plus C plus D. So this is how to find the perimeter of a trapezium. Now don't forget that we said that AB is parallel to DC. Now to the area. The area of a trapezium is given by half times the sum of the parallel sides. So the parallel sides are A and then B. So the sum of A and then B times the height. So this is also how to find the area of a trapezium. So assuming that we are asked to find the area and perimeter of this trapezium, how are we going to solve this question? Now the area of a trapezium we know is given by half times the sum of the parallel sides, so A plus B, times the height. So we have half times A is DC, which is 9 centimeters, plus B is AB, which is 13 centimeters, times the height, which is 6 centimeters. Notice that always the height has to be perpendicular to the line AB. Okay, it should be perpendicular to the base. So that is 6. Now 2 goes into itself once and then into 6 3 times. 9 plus 13 is 22. So we have 22 times 3, which is 66. So we have 66 centimeter square. That is the area. Now let's talk about the perimeter. So the perimeter is also given by A plus B plus C plus D. So we have A to be 9, plus B is 13. We have C to be 8, and then we have d to be 5. 9 plus 13 is 22. 22 plus 8 is 30. 30 plus 5 is 35. So we have the perimeter to be 35 centimeters. Now let's talk about a rhombus. So a rhombus is actually a parallelogram which has all the four sides to be equal. So this time we have all the four sides to be equal. Now the opposite angles are also equal. The opposite angles are also equal. So let's say this is A, B, C, and then D. Then we have all the four sides to be equal. So if AB is L, then it means that BC is also L, CD is also L, and then AD is also L. The opposite angles are equal, and the diagonals bisect each other at right angles. They bisect each other at right angles and also bisect the opposite angles. Therefore, we say that the side AB is equal to the side BC is equal to the side CD and also to the side AD, and that is equal to L. Now, the perimeter of a rhombus is given by, since all the sides are equal, if one of them is L, then we have L plus L plus L plus L, and this gives us 4L. So this is the perimeter of a rhombus. Now to the area. Now the area of a rhombus is given by the length of the base times the perpendicular height. Now since a rhombus is a parallelogram, then we are going to have what we call the perpendicular height. So you can have the perpendicular height, okay, the height which is perpendicular to the line AB. So this is the perpendicular height. So if you want to find the area of a rhombus, you can use the formula area equals the base length times the perpendicular height, or better still, you can use a different formula which says that the area of a rhombus is given by half times the product of the diagonals. The product of the diagonals. So that is the side AC times BD, the side BD. So that is half times the product of the diagonals. That is one form of finding the area of a rhombus. So given that the diagonals of a rhombus are 8 centimeters and 6 centimeters long, find its area and perimeter. So first of all, let's draw the rhombus. So we have something like this. And this is A, B, C, and then D. And then we have the diagonals AC and then BD. Now we are told that the diagonals of this rhombus are 8 centimeters and 6 centimeters long. So we say that let AC be 8 centimeters. Now if the center, if this point is O, then if AC is 8 centimeters, then AO will be 4 centimeters, and then OC will also be 4 centimeters, BO will be 3 centimeters, and then OD will also be 3 centimeters. Therefore, if we want to find the area of this figure, then the area will be half times the product of the diagonals. So we have 8 times 6. 8 times 6 gives us 48. So half of 48 means that we have our answer to be 24. So that is 24 centimeter square. This is the area. Now to the perimeter. So the perimeter is given by 4 times the length of one of the sides. Now, since all the sides are equal, if we are able to calculate one of the sides, then we can multiply that value by 4. Now, let's consider the triangle DOC. So for triangle DOC, this is a right angle triangle because we have the angle DOC to be 90 degrees. So we can redraw this triangle in this form. So we have D to be at this point. This is O, and then we have C. OD is 3 centimeters. OC is 4 centimeters. And then we have this angle to be 90 degrees. So we are going to find the length CD, which happens to be one of the sides of the rhombus. Now, after finding this value, we are going to multiply it by 4 to get the perimeter. So using Pythagoras theorem, we say that DC square is equal to OD square plus OC square. So that is equal to 3 square plus 4 square. 3 square is 9, 4 square is 16. And then we have DC square to be 25. So we take the square root of both sides, and then we have DC to be 5 centimeters. So this is the side DC. Now, if DC is 5 centimeters, it means that AB, BC, and then AD are also 5 centimeters. So the perimeter is basically 4 times 5 centimeters, which gives us 20 centimeters. So we have the perimeter to be 20 centimeters. So now let's move on to a kite. So a kite is also a 4-sided figure with 2 pairs of adjacent sides being equal. So this is how a kite looks like. We have 2 pairs of the adjacent sides being equal. So this is equal to this, and then we have this also being equal to this. Now let's say this is A, B, C, and then D. Now we have one of the diagonals being a line of symmetry which bisects 2 of the angles. So that is the line AC, and then it bisects the angles DAB and then DCB. And the other 2 angles are equal. That is, angle ADC is equal to the angle ABC. So this is the angle ABC. The diagonals also bisect each other at right angles. So the diagonals bisect each other at right angles. So in summary, we say that for a kite, AC is the line of symmetry. AC is the line of symmetry. And then AC bisects the angles DAB. This is DAB, and then DCB, this angle, and the angle DCB. AC also bisects BD at right angles, and then the angles ADC and then ABC are equal. So the angles ADC and ABC are equal. Now to find the perimeter of a kite, is given by the sum of the lengths of all the 4 sides. So that is the side AB plus BC plus CD plus AD. This is how to find the perimeter of a kite. And also for the area, it is given by half times the product of the diagonals. So these are the diagonals AC and then BD. So half times the side AC and the side BD. So we have a question here. The diagram shows a kite PQRS with diagonals of length 12 centimeters and then 22.4 centimeters. Find the area. So we have a kite here, PQRS. We have the diagonals PR and then QS. Now if you add the value of, let's say if this is E, so if you add the value of PE to ER, then that is 8 plus 14.4, which gives 22.4. So that is one of the diagonals. And then we have QE to be 6 centimeters, and because we have the other diagonal to be 12 centimeters, it means that ES will also be 6 centimeters. So basically, if you want to find the area of this kite, then that's going to be half times the product of its diagonals. So that's going to be half times the length PR times the length QS. So we have half times PR is 22.4. So 22.4 times 12. 2 goes into itself once, into 12 6 times. So literally we have 22.4 times 6. And then when you multiply the 2, you are going to get 134.4 centimeter square. This is the area of this kite.